Hi, this is Lee from the Robby team. In our last video, I demonstrated having Antwerp respond to spoken commands with both a programmatic and vocal response. In it, I said that in this video, I'd show what it takes to set up the Robby framework to support speech recognition and text-to-speech functionality. So let's get to that. First, we'll open up the framework's UI and go to the Channel Builder dialog. Now we'll load the new channel I created for this, aptly named the Antwerp Speech Channel. You can see that we have one connector on each side of the channel. On the MCP side, we have a string connector that can pass strings from the MCP to the channel. We'll dig further into how it can be used with the speech channel in a future video. On the device side, you have a connector that we called a speech connector. I'm going to open up the configuration dialog for it so you can see what it takes to build the vocabulary we use in Antwerp. The Windows 10 speech library uses an object referred to as a grammar. There's three main components to building a grammar. First, each one has what I call an attention phrase. There's only one of these for each grammar. It consists of one or more words that should have a distinctive sound. It lets the device know you're talking to it. Think of Hey Cortana or Hey Google. For Antwerp's grammar, we'll use Hey Antwerp for the attention phrase. For those of you who saw the last video, you might notice that I changed it from just Antwerp. Guess it wasn't distinctive enough, and I was getting quite a few false recognitions. So I added the Hey, and it seems to help. In addition to the attention phrase, there's a collection of recognized phrases. In other words, phrases the device will recognize if spoken after the attention phrase. Each recognized phrase is paired with a resulting string command that's triggered by it. So the speech engine effectively turns the recognized spoken phrase into a string that can contain whatever you want and be used pretty much however you want within a program. So here you can see the simple grammar I've set up for Antwerp so far. You can also see that in the config, in addition to the recognized phrase and triggered commands, we have a spoken response for the phrase, making it so the robot can give a text-to-speech response for any spoken command I give it. The idea here is that with the speech connector acting as a device connector for the channel, I can give a spoken command and it will immediately pass the triggered command string to the MCP through the channel. The other component to the speech channel is a display gadget that will show the response strings as they are sent through to the MCP in the testing console. Now let's take a look at the full network running in the testing console. So we're going to load the Antwerp network and open up the testing console. As I stretch it out here, you can see all the display gadgets for the three channels included in the network now. When I speak a command like, Hey Antwerp, say hello.
Hello, my name is Antwerp. My goal in life is to fetch a beer from the fridge.
You can see the command triggered by that phrase is W in the display gadget for the speech channel. Now, if I say, Hey Antwerp, move forward.
Moving forward.
You can see the F command in the response string, but you don't see the message being passed through to the body movement channel. It might be obvious to those of you who saw the last video why this is, but to make sure everyone understands, in the code for the little WPF app I use in our videos to demonstrate things working, remember that it was in that code that I linked the commands passed from the speech channel to the body movement channel. Without that orchestration by the MCP, there won't be any interaction between the different channels. Well, that's it for this video. In our next video, I'm going to demonstrate another freebie we get from the framework. If you think about the way channels work, it's a small leap to build an actual peer-to-peer network with the framework. What I'm talking about here might consist of a remote MCP channel or a remote computer channel or a remote robot channel, etc. The device on the other end of a TCP connector can be any type of device you want as long as it can talk in TCP, including other computers and other robots running the framework. As long as I pass JSON with the correct schema into the channel, it really doesn't matter what type of device it came from. It's a simple thing, but if you think about it, it opens up a pretty wide world of possibilities, including having robots communicate with each other or having a central computer orchestrating multiple robots. We'll take a look at some of those possibilities next time. So that's it for now. Thanks very much for watching.